Hey guys. All right, so we did rectangular to polar yesterday. Today we're going to do polar to rectangular. Okay, it's a very specific formula, and we're actually going to, figure out the formula together based on drawing this vector. Now that we know what it looks like, in in polar terms, it's basically just, the vector or the ray at this specific angle, and given a length of this as far as the hypotenuse. So pretty easy, and we're going to work backwards to find the rectangular, the I and the j coordinates. Okay, so it's actually really easy. Grab some graph paper, make sure you're ready to go. Pause the video if you need to, so you can go grab it. All right, so let's think about this. An angle of 60. Now let's remember that, what our unit circle looks like. And I'm going to cheat and I'm going to draw a circle on here just because I can. Okay, so just as a reminder, and you don't have to do this, this is just so that you have a visual of where the angles are. Now, if you want to go ahead and draw the circle, go ahead. I'm not going to count it against you. Okay, so 60 degrees, remember when we did our unit circle, it was like 30, 45, so 60 degrees was probably about right there, okay? And we don't have to make it accurate as far as the ray. We're just going to go ahead and label the hypotenuse, 6.14, because that's our magnitude. Oh, nope, not 6.14, 6.14. All right, so 6.14. Okay, so basically what we're trying to find, given this degree, right, and that length, we're basically trying to find these two measurements, right? Right, because this would be the I and this would be the J. And we're going to try and work backwards in order to find them. Well, we learned really how to do this dueling with trig and dueling with the unit circle, right? I mean, it really actually is a, what do you want to call it? It's like solving for, it's basically solving for like a right triangle. It really is. If it's whatever the angle is there, you make it into a triangle, you have your right angle there, and you're basically just solving for sides. Okay, so let's think about how we would set this formula up. If I was looking for side J, okay, so we would say that the cosine of 60, oh, not the cosine, excuse me, I'm having a moment, aren't I? That's opposite, so that's the sine of 60, isn't it? So sine of 60 equals J over 6.14, right? And if I want J all by itself in this equation, okay, I mean, I could do this and I could solve for J, no problem, and then I would have the, the J vector, or the part of the vector, and then I could go back and do cosine and I could get the I. Okay, so really it is actually this formula. If I wanted J by itself, and we've, done this before, we would have to multiply both sides by 6.14. So J is going to equal 6.14 times the sine of 60 degrees, because that's the angle that's there. Okay, and that means I is going to equal, doing the same exact thing, cosine of 60 since it's adjacent. So I is going to equal 6.14 times the cosine of 60. And really, again, that's all we're doing. If you want to go ahead and draw the triangle and with the circle on your graph to help you get a visual, do it. Because really all you're doing is solving for a specific side of a right triangle. Okay, given a hypotenuse and given one angle. So the specific formula, the generalized formula, right, if you take a look, 6.14 is our magnitude, right? And then J is the sine and I is the cosine of whatever your directional angle is. Okay, so that being said, the actual formula, there it is your magnitude for I times the cosine of the angle, and J is the magnitude times the sine of the angle. And that's really what it was, just by solving the side of the triangle, or the sides of the triangle. So if you have your calculator handy, let's go ahead and actually solve this, just so we can see what our coordinates would be in this case. And again, remember please that your calculator does need to be in degree form. So 6.14 times the sine of 60 degrees is going to be 5.32 rounded correctly. Okay, so that's 5.32 J. All right, and then this one is going to be 6.14 times the cosine of 60 degrees. And that one's going to equal 3.07 I. So we now actually have our vector, right, in rectangular form. And notice that neither one of those is negative because you are in quadrant 1 and it better not be negative. Now, when the angles get to be in other quadrants, then you're going to get some negative answers, and we'll deal with it because, you know, you're supposed to. So that would be it. That would be vector v in rectangular form. So I'll let you go ahead and copy the formula, and then we'll go ahead and do some more examples of it. And I hope y'all are excited. I will be back on Monday, and then we'll be doing a lot of the word problems that deal with combining these type of vectors, and it's actually really fun. And you get to actually see some real-world applications on how we use these. Okay, so let's try the next example. Okay, so given a magnitude of 8.10 and a degree of negative 40. Okay, so again, if you want to plant your circle in the middle of that, and it doesn't have to be a nice circle, you can always find something to trace if you really want to, but just so that you remember where, or give a good approximation of where negative 40 degrees might be. If you're going negative, remember that means you're going clockwise. So down from the starting point. Okay, so this is about 45, so 40 would probably be about here. Again, just use it as a reference point. That way we can make our right triangle. Okay, so the hypotenuse is 8.10, and the angle created is negative 40. And we're going to do the exact same thing. We're going to solve for I and j. Okay, so in this case, this is I, and this is j. And I better be positive and j better be negative when you're done because of where you're graphing it. So, same thing for before. I want I, right? That's going to be, if I set it up the regular way, that's going to be the cosine of negative 40. Wow, I'm having time writing today. Cosine of negative 40 equals I over 810, right? And then if we want I by itself, I is going to be 810 times the cosine of negative 40. So whatever that is, times cosine of negative 40, and that's going to be 6.20. Okay, and then setting up the other one, sine of negative 40 is going to equal j over 8.10. Right, so j equals 8.10 sine of negative 40. So 8.10 sine of negative 40 is going to come out as negative 5.21, which is, again, what it was supposed to. It was supposed to come out as a negative. All right, so we have our vector in, again, polar coordinates, or not polar, rectangular coordinates from polar. And it's really just using the idea that you can make the ray in the hypotenuse of a right triangle, so that you can basically state it in either direction. This was vector u. There we go. Okay, so, and again, either like this or with the pointy brackets. A couple of you, I think, are still having some issues on some of your other vector homeworks. If you don't write it in the correct form, you're going to get dinged. I'm going to start counting it as wrong. So make sure you're writing it in the correct form. All right, so one more example, and then I will let you get started on what you're doing. All right, so example 3. All right, so let's see, vector w this time. Let's see, magnitude of 4.8 4.5 and an angle of 210 degrees. Yeah, 210 degrees. We know that, I mean, that's one that we know that works. But let's go ahead and put it in. All right. So there we go. And I'm not going to draw the circle this time just because, in case you're not, that way you can see it can be done without it. It's just, again, making an estimate of where it is. Now, if you remember your circle, you have 0, 90, 180, 270, so 210 is somewhere around here. So just make a right triangle. That's 210 degrees because that goes all the way around. And the length of the hypotenuse is 4.5. And again, you are solving for I, and I better be negative, and J also better be negative in this case. Okay, so let's go ahead and set it up. So again, cosine of 210 equals I over 4.5. So that means I equals 4.5 cosine of 210. Okay, and that's going to equal 3.90, negative 3.90, and I'll give you a minute. Go ahead and you do J. Alright, so J, and I'm not going to actually write out the whole thing as far as the setup, but J should be 4.5 sine of 210. And 4.5 sine of 210 is going to be negative 2.25. Okay, so in rectangular coordinates, we have negative 3.90, negative 2.25, or negative 3.9I minus 2.25J. Your choice on how you write it, but you better write it correctly. Okay? Alright, so you have, I think, about 8 problems to do that are like this on this, and then like I said, on Monday we'll actually get to the word problems, which will be really fun. So, go ahead and get these. 8, 9, 50, 51, 52. So I lied. Sorry, it's like 10 problems. All right, so 10 problems. You really should be able to get a good start on this before you even leave today so that you don't have as much homework over the weekend. Be good. I will see y'all on Monday.